Hi, my name is Ms. Fung, and today we're going to continue with similar figures. If you've forgotten the difference between similar and congruent, then click on the link and it'll take you to my previous video. Now we remember from last time that similar figures have the same shape, but they are different in size. And the other thing we notice is that the angles, the matching or corresponding angles, are all the same or equal. Now the other thing we're going to explore today is that if one side gets bigger, then the other side gets bigger as well. And we can explain that by saying the corresponding sides have the same ratio. So they get bigger by the same amount, or they get smaller by the same amount. Let's have a look at these two triangles. So we can see clearly that this one is smaller than that one. And we can see that the 6 became a 12, the 4 became an 8, and 7.5 became 15, which means this one became twice as big. Or in other words, we took this and we times it by 2. We call this 2 the scale factor. So that times the scale factor gave us that. Now, how do we get the scale factor? How do we get 2 just now? From the 12 to the 6, 15 to 7.5, how do we get 2? Now we look at the length of the image over the length of the object. 12 over 6 is 2, 15 over 7.5 is 2, and 8 over 4 is 2. So that is called the scale factor, and it's the ratio of the corresponding sides. So the corresponding sides ratio, that one, 2, 2, 2, will be the same for similar figures. Let's look at an example where they're not similar figures. So the length of the image over the length of the object. We can see that, 11 over the 6 and 10 over 4. Now, if you're wondering why that I didn't match the 11 with the 4, you would match the longer side, which is 12 over there, with the longer side, which is 7.5. And then you'd match the shorter side is 4 and the 10, but always the image on top. So the 10 over the 4, and then the middle value. So what's the middle value? 11 over there. And what's the middle value? 6. So you have to match them in order. So that's how you find the corresponding sides. Now we can see that the three ratios are not the same, and we can clearly see that they're not the same triangle, as in they're not similar triangle. So so to prove that they're not similar triangle, you would find the ratio of the sides and see that they're not matching. Let's go back to that example where they are similar triangles. So here we have the two images again, and we can see the scale factor is 2. We would describe these as similar by putting that wiggly, squibbly symbol over there. So that means similar. Triangle ABC is similar to triangle DEF. Now, how do we show that? We show that by looking at the side DE. So DE, the side DE corresponds to the side AB, and then the side EF, 15 was over BC, and the last DF is over AC. So the corresponding sides. So this to this, giving us number 2, gave us an enlargement. It went bigger. What if we swap them around? What if 12 now became 6? How would we write the ratio? We would have the image over the object. So AB would be over 12, DE. So 6 over 12 is half. BC, 7.5, will be over EF, 15. And lastly, AC, the 4, will be over DF, the 8. So remember, it's always the image over the object. And what do we get? 6 over 12 is half, 7.5 over 15 is half, 4 over 8 is half. So now, when we go smaller, our scale factor is half. And they're still similar because these ratios are all the same. So we have a reduction, smaller. So whenever we see the scale factor to be more than 1, we can say that it's getting bigger. Whenever we see the scale factor is less than 1, we can see that it's getting smaller. You might want to take a note of that. Okay, remember last time we had a look at congruency conditions, and out of the 4, Now that one was the tricky one because we had to remember that the angle was in between the sides and not on one side of the two sides. So I brought up the congruency condition so that we can compare them to the similarity condition. Now, the similarity condition does not have angle, side, angle. For similarity conditions, instead, we have angle, angle, angle. Remember, when the angles are the same, they are similar. Perhaps you want to copy these down next to the congruency conditions from last time so you can remember the difference. So we have side, 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 angle, 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 side, and right angle, hypotenuse, and side. Remember though, this time we're not making sure the sides are the same, like in congruent conditions. This time we're making sure that the sides have the same ratio. Let's do an example to see how the conditions work to prove that they're similar. So here it says, prove that triangle A and B are similar triangle. Now looking back at the four options, we can see that we're going to use side, side, side. And when we say side, we don't mean that 15 will be the same as 12. We're going to match the ratios. And how are we going to do this? Well, we're looking at the ratios of the corresponding one. So remember, the longest one goes with the longest one. We look for the shortest, goes with the shortest, and the in-between goes with the in-between. So let's do the longest sides. We have 15 and 12, which gives us 1.25. Then we have the middle side, so 13.75 matching with 11. That ratio is also 1.25. And lastly, the 10 and the 12.5, is that equal to 1.25? Yes, it is. So the three ratios of the sides, corresponding sides, are the same, and therefore triangle A is similar to triangle B. Don't forget to put the condition in brackets to get full marks. So see, the longer side, the middle side, the smaller sides. Now let's have a look at this question. Which pair of similar triangles give reason? So we have to see whether these two are similar, or those two are similar, or those two are similar. We have to match them up. Now let's check the condition. Which of these conditions are we going to use? We can see that it is side, angle, side. So let's compare A and C first, for no particular reason. So let's look at the 20 would match with the 10. That gives us a side ratio of 2. And the 15 matches with the 6. That gives us a ratio of 2.5. So A and C are not similar. Let's try A and B. We have 15 over 10 gives us 1.5. And the 9 and the 6, the shorter sides, gives us 1.5. So they're the same. So A and B are similar because the angles are the same and the side ratios are the same. So the side ratio, angle, side ratio. Now, one of the silly mistakes I see is students don't match the right sides. Remember, the longest sides always matches up to find a ratio, and the shorter sides. Let's have a look at this tricky question. Prove that the triangle ABC, so this top one here, is similar to the triangle AECD, so this little one at the bottom. How are they similar? Now we can see that this angle here, the angle BAC, so this angle here, would match up with this angle over here, angle DEC, because this angle and that angle are alternate angles. What else matches? The angle ABC, this corner here, would also match this corner over here, angle CDE, because they're alternate angles. So we've done these two angles with these two angles. Lastly, we have to compare these two angles. So for the top triangle, that's angle ACB. For the bottom triangle, it's angle DCE. And they are the same because they are vertically opposite. So you have to give the reason why they're the same if there are no numbers. So because these three angles are the same, we can say that triangle ABC is similar to triangle DEF by the condition AAA. Remember to put the condition in. Okay, so remember, if you're going to say angles are the same without numbers, put the reason in. Without the reason, you will not get the marks. Let's have a look at this example. A 2-meter lamppost casts a shadow of 3 meters long. Find the height of a tree to cast a shadow 15 meters long. This is a really awesome way to measure how tall something is if you can't reach its height. Let's draw a diagram. So it's a sunny day because we have shadows. We want to figure out the tree and the lamppost. For the lamppost, we have a shadow of 3 meters and it's 2 meters tall. For the tree, we have 15 meters is the shadow, so the line at the bottom. Now we need to figure out how tall the tree is. Now because of similar triangles, we can use corresponding sides to figure out how tall the tree is. Now the height of the tree is corresponding to the height of the lamp. Now the shadow of the tree corresponds to the shadow of the lamp. Now we know that the ratios of the corresponding sides are going to give us the scale factor and they're going to be the same because it's a similar triangle. So now that we know they're the same, we can write an equation. Let's call the height of the tree x. So now what's the opposite of dividing by 2? We have to multiply the other side by 2. Now 15 over 3 is 5. 5 times 2 is 10 meters. So the height of the tree is 10 meters. So with this in mind, we now know how to measure how tall something is, even though we can't reach the top of it. How awesome is that? So maths is pretty cool. Today's questions might be a little bit tricky, so I recommend watching the video again, and this time pause at the start of each question and then see if you can do the solutions yourselves and then click play to watch and see if you've done it correctly. Thanks for watching and I'll see you next video.